Alright, welcome back everyone. This is Tila from My Teacherla, and today's topic is on circular measures. But before that, please, if you've enjoyed my content so far, do hit that subscribe button and that'll be a great support for me. Okay, so today we'll be looking at 5 different questions from past year topical question papers on circular measures, and I hope that I can cut short the time. It shouldn't be 50 minutes. This is just the recommended time for you to finish, but I hopefully this video doesn't last too long. I don't want to bore you to death. Okay, so circular measures is actually kind of like one of my favorite topics after differentiation and integration. I don't know, something about circles just intrigues me. Let's get on to it. So question number 1. So the figure shows a circle with center O and radius 10 centimeter. The lines XA and XB are tangents, okay? And angle AOB is basically 2 pi over 3 radius. So we have some given information. So we're required to find the perimeter of the shaded region. I think I'm gonna just zoom in a little bit. Okay, that's better. So find the perimeter of the shaded region. So we have this shaded region right here. So a couple of things that we need to start looking at is that when we have a tangent passing through a circle and it touches the radius like this, you will end up getting a 90-degree here. Okay, right. So that's something that we should look at. Now, since we're just looking at perimeter, which means we want to be able to find out this length, okay, and this length. Now, whenever you have a situation like this with 2 tangents touching through the radius and intersecting at a common point, you will always get 2 equal sides. So that's just the property of a circle and a tangent passing through it with an intersection at a common point. All right. So then one last thing that you need to find the perimeter for is this arc. So the arc AB. So let's start with the arc AB. So in order for us to find arc AB, we use the formula R theta. Now, one PSA is that whenever you're talking about the topic on circular measures, please try to make sure that your calculator is in radian mode. Okay, not in the degree D mode, especially when you're using trigonometrical functions. So in circular measures, we use radian. Okay. All right, so R theta. So the radius here is the radius that we're going to get from the circle, which is 10. And the theta is basically 2 pi over 3. So multiply 2 pi over 3. And therefore, you will end up with 20 pi over 3. So let's just keep this first. So that's the arc is done. Now, what else am I missing? I'm missing the AX. So if you just look at it, it might not be as easy to find out, but if I were to just divide this shape into 2, okay, I'm gonna end up getting a very nice right angle triangle. And this right angle triangle already has a 10 centimeter height. So it kind of makes it a lot more simple because I can also make use of this angle here. So my original angle was 2 pi over 3, but if I were to divide this by 2, I'm going to get a new angle. The reason why I divide by 2 is because we just divided the entire shape by half. So this should be a new angle right now. This should be pi over 3. Now, once I have that, all I need to do is to utilize my trigonometry. So tangent pi over 3 must be equivalent to opposite over adjacent. Therefore, making AX as my subject, I'm going to get 10 multiplied by 10 tangent pi over 3. So which gives me about 17.32. All right. Now, that's basically it. I found this and I found this, and I know that this and this must be the same. Okay, so I'm gonna just add them all up together. Okay, let me just use a red color. So perimeter must be equivalent to 2 multiplied by 17.32, because we have 2 of them, plus 20 pi over 3. And the final answer in 3 significant figures is 55.6 centimeter. So that's your perimeter. Alright, so now that we found the perimeter, the next question with the same shape, okay, is to find the area of the shaded region. Now to find area, the formula of area, so earlier we just learned that the formula is S equals to R theta for the arc. So that's the formula of the arc. So if it's about the area of a sector, okay, so the area of a sector is actually half R square theta. So these two formulas are extremely important in the topic of circular measures. Alright, so with that, let's move on. So we are looking to find the shaded region area. So how do we do this? So first of all, I want to be able to find the area of sector AOB. Okay, so let me just get that up. Area of sector AOB. So this will give me half 10 square 2 pi over 3. That's the area. Okay, so this is giving me about 104.7. But that's just this sector. Now the reason why I'm trying to find this sector is because in order for me to find the shaded area, I need to take the entire area here of the 2 right angle triangles combined and minus with this area of sector. So I'm just going to find this first. Okay, now my next step is trying to find the area of one triangle. Okay, or I might just as well combine them in this case. So area of 2 triangles, area of, let me just name it OAXB because it's O, A, X, and B. So these are the area of the 2 triangles. So I'm going to use the 2 as the multiplier while I just find one of it, times by half base times height. Okay, and then let me just substitute the values inside. So the base of it is 17.32, as we found out earlier that this was 17.32, whereas the height has already been given to you, which is 10. Okay, so this ends up with 173.2. And finally, we just need to minus this one. So it's a blue color now. So area shaded is equivalent to area of OA of OAXB minus area of sector AOB. I apologize if my writing is just terrible. Okay, I don't know why my writing pad is not helping me. It's not as ergonomic as I thought. Okay, so anyway, so this is 173.2 minus 104.7. So this should give me 68.5 centimeters squared. I'll always make sure that my answers, my final answers, are always in 3 significant figures. Alright, so that's the end of question number 1. Let's move on to see what other type of questions that we can come across. Okay, so this one. So the diagram shows a right angle triangle, rightly so, and you have a sector of a circle attached to that triangle. Alright, so the first thing is to show that the length of AB is approximately 10.1. Now, notice that AB is just an angle, a line in a right angle triangle. So which means that we can actually make use of trigonometry. So what I'm going to do is that I'm going to use, this is radius, radian, okay, 1 radian. Okay, I'm just going to use sine of theta is equals to opposite, okay, over hypotenuse, right? So we know this hypotenuse value because this is a radius of the sector. Therefore, if this is 12, this should be 12. So that gives me hope. Okay, now all I need to do is then substitute the values and make AB as a subject. So AB is equivalent to 12 sine 1. Why is the 1? Because radian. So 1 radian. So in your calculator, again, as I said, please make sure that your calculator is in radian mode. If it's in degree mode, if you put sine 1 here, you will get the wrong value. Therefore, once I finish up the calculation, I'm going to get 10.1 shown. I'm done. Okay. Next, we're supposed to find the perimeter of the shaded region. Notice that in circular measures, pretty much everything is either finding, and not to say everything, but mostly it's about finding perimeters or finding area of shaded regions. Okay, so now let's look at the perimeter. This shouldn't be too difficult. We just need this big one, big curve. We already have this. We already can find this guy. And finally this guy, right? Okay, so I mean, we already have this. This is 10.1. I forgot to write. Okay, so first of all, let's find AC. So AC, just using basic trigonometry, you will end up with 12 cos of 1, okay, which is equivalent to 6.484. Just use trigonometry. I'm not going to go into details. Okay, and the next is I need to find the angle. Okay, so there's a missing angle here because I can't find my arc without knowing this angle. So in order for me to find this angle, I need to know that pi is equivalent to 180 degrees. And in a straight line like this, my total angle is 180 degrees or pi. So we're going to make use of pi. So let me just define pi here as 3.142 because that's the value that I'm going to use. Okay, so I'm going to try to find this. So in order to find this, I just take 3.142 minus 1 radian. So I'm going to end up with 2.142 radians. Okay, so I'm just going to use this, okay, in order for me to find S equals to R theta for my BD. Therefore, length of BD is equivalent to R, which is 12, times by 2.142. Okay, this should give me about 25.7. I think we kind of have pretty much everything that we needed. Let's just put them all together and calculate the perimeter. So the perimeter is equals to 10.1 plus this the entire BD, which is 25.7 plus this 12 plus AC, which we found as 6.484. And finally, I get the final answer, which is about 54.3 centimeter. Okay, I hope that's clear. All right, so let's look at question number 3. The diagram shows an isosceles triangle, which is an important information. Okay, and blah blah blah. I don't want to read this. Okay, so we are required to again find the area of the shaded region. So in order for me to find the area of shaded region, let me just write down what we need. Area shaded must be equivalent to area of the big triangle, okay, minus area of sector. Okay, so this is the sector and this is the big triangle. All right, so there is a new formula that I would like to introduce, which is area of triangle or area of isosceles. Oops. Okay, area of isosceles. Okay, it's actually equivalent to half r squared sine of theta. Now this is only true for when the triangle is an isosceles, okay, and you actually can find the value of the angle in terms of radians, and this radians must be the angle between the two isosceles legs. Okay, so half r squared sine theta. Now, if this looks familiar to you, it probably should, because there's another way of finding area of triangles, which is, this is basically derived from half AB sine theta. So this is a more general way of finding area for a triangle. All right, so just keep this in mind as well, because there will be a question, I think, that we might need this. But anyway, let's use this first. So half, my triangle's leg is about 18, therefore 18 squared sine 1.5, okay, minus the area of sector, which is half r squared, this is 10 squared, just theta. Okay, for area of sector you don't have a sign, just theta, which is 1.5. Alright, so let's go down and calculate this. This will give me 161.594 roughly, and you get a 75 over here. Minus them together and you should be able to get 86.6 centimeter square. Alright, so let's go to the next part of the question. Okay, so find the perimeter of the shaded region. So you need to find the perimeter of the shaded region now. So what is missing? So this is quite easy to get. This is also quite easy to get, because 18 minus 10, I'm going to get an 8. I'm going to get an 8 here. All right, what else? AC. So in order for me to get AC, it's just r theta. So my radius is 10 times my 1.5. So I'm going to get 15 for that. Okay, what else am I missing? What else I need? Oh, I need a BD. So how do I find BD in our case? Now, there are many ways of doing it. You can separate this into a half triangle and then try to find using trigonometry and such. But I'm going to use the sine rule. Okay, so the sine rule is basically saying that length over the sine of that length is actually equivalent to another angle and another length that are opposite each other. Okay, so I'm just going to use that. Now, in order for me to use that, first of all, I need to rightly find this particular angle. How do I do that? I know that in a triangle, the total angle is 3.142. It's 180 degrees, or pi. So I'm going to minus 1.5. Okay, and I'm going to divide it by 2 because I want just one angle, not the both of them. So this is going to give me 0.821 radian. So angle here is 0.821. Then I'm going to apply the sine rule. So I'm going to apply the sine rule to get BD. So I know that BD over the angle opposite of me is 1.5. Oops, I forgot my sine. Okay, sine 1.5. And this must be equivalent to 18 opposite. Okay, the opposite angle is sine 0.821. Rearrange and get my PD in terms of everything else. I should be able to get 24.5. Okay, check. What else am I missing? I don't think I'm missing anything else. I have this, this, and finally the arc as well. Okay, so that means it's time to add them up. So the perimeter is equals to 24.5 plus 15 plus 16. Where's the 16 coming from? 8 plus 8. Final answer would be, I think 55.5 centimeters. Wow, so 555, nice number. Okay, so we're done, I think, with 3 different questions. Let's look at question number 4. Ah, nothing shaded. That's new. Okay. Now this diagram shows 4 straight lines. You have 4 straight lines, yes. And I see an arc. I see an arc with the center of the circle right here. Okay. We are required a perimeter. Why am I not surprised? Find the perimeter of A, B, C, D, the entire thing. Okay. Now a couple of things to really look at this is that AD here is something that we need to find, and CB here is also something that we need to find. I mean, you find either one is good. I'm just going to stick with AD. Okay, so I need to find AD. Now, the first thing that I need to understand is that this AD is not a right angle triangle. It's just a triangle with no equal sides and lengths of angles and so on. So what do we need to do? We need to use the cosine rule. But in order for me to use the cosine rule, I need to know what angle is this. Right? I don't have any angles given to me. So I need to know what is this. Now, if you recall, I don't know, this is something that you've learned some time ago. If you have 2 intersections of line that are straight, the opposite angles are always equal to each other. Okay? So which means, since this is given that this is pi over 6, this angle is pi over 6. And these 2 angles must also be the same. That also means that this shape of triangle and this shape of triangle are the same size and they're identical. Okay, so anyway, my journey right now is to try and find out what angle is this. So again, we make use of the knowledge that the entire circle is 360 degrees or 2 pi, right? So 2 pi is what I'm going to make use of. Okay, wait, let me just write it somewhere here. Okay, just need some space. Okay, so 2 pi, I'm going to minus this with this guy, okay, and this guy. Okay, so it's 2 pi over 6. How did I get it? I add them up together, I get this. All right, so then I will probably be getting, I think, 5 pi over 3. That's something that I'm supposed to get. Okay, so this 5 pi over 3 is for this and this. So I just need 1. So I divide it by 2. I'm going to get 5 pi over 6. So that's basically this angle. Okay, I know. I don't know why I beat around the bush to get this, but yeah. Anyway, let's move on. So my goal is to again find AD. Therefore, I can now use my cosine rule. AD squared is equals to 20 squared plus 10 squared. This is cosine rule. If you're not sure what it is, please look it up on Google. Minus 2, 20 again, and 10. And finally, use cos of the angle in between the 2 lengths, which is 5 pi over 6. Calculator must be in radians. Okay, and try to find this. This should give me about 846.410 ... All right, so this is AD square. I need AD. Therefore, I'm just going to square root this entire thing, and I'm getting the value 29.1. I'm going to keep this value. Okay. Now that I've found the value of AD, BC should be the same. Okay, this is 29.1. We know that. This should also be 29.1. Now what else that is missing? We are missing this one and this one. We already know the angles, so to find the length is quite easy. So just r times theta. Okay, let me just rewrite this. So r times theta for the first one would be, the big one is 20 pi over 6. 20 multiplied by the theta. For the small one, okay, let me erase this, it's causing confusion. Okay, for the small one, it should be 10 multiplied by pi over 6. So this is what I get. Alright, so I have all the 4 components that I need to calculate the perimeter. So let's calculate. Alright, perimeter equals to 2 multiplied by 29.1 because there are 2 sides. Okay, plus the larger sector. Okay, the perimeter of the large arc, sorry, plus 10 pi over 6, the perimeter, the length of the small arc. Okay, join them up together, calculate, and you should be able to get 73.9 centimeter. Okay, so that's part 1. I'm guessing there might be a calculation for area. Let me see. If I'm going too fast for you, please feel free to always pause in between and follow through. Also, please do subscribe to the channel if you find my content helpful for you. Okay, I'm taking a breather. Find the area of ABCD. So ABCD. Basically, they're asking you to find the area of the entire shape. Alright, so this shape is made of 2 sectors and 2 triangles, right? Now earlier I mentioned that you might end up having to make use of this guy. Half AB sine theta. Alright, this is the formula for the area of a triangle. So we're going to make use of this. There are 2 triangles of to find the area for, and we know that this value was earlier 5 pi over 6. Right, so let's try that first. 2 triangles, okay, and each triangle is half AB, okay, A and B, sine 5 pi over 6. Okay, I'm using this formula to calculate the area of this triangle and this triangle. I just multiply them by 2. Oh my god. I think I need water. Anyway, okay. So surprisingly, I'm getting a very nice value for this. I'm getting 2 times 50. So I'll end up with 100. Okay, so this entire thing is 50. Just nice. Alright, once done, what about the area of this guy? Okay, so small sector is this. Small sector equals to half 10 square pi over 6. This gives me 26.18. Okay, and then let me calculate the large sector. Okay, I'm looking at areas here. So half, same thing, but just that the only difference is the length is different. The radius length is different. Okay, 104.72. So we have 3 different items that we wanted. So total area, or area, is equivalent to 100 plus 26.18 plus, oh my god, okay, the OCD is killing me. Alright, 104.72, kind of looks weird now. Okay, this entire thing is equals to 231. Oops, forgot. It should be cm squared. Okay, so we're almost there. I have one last question to go, which is this guy. Okay, so this question is slightly more interesting because it was quite different from the rest of the questions that I saw. The fact that you are given unknowns on top instead of values, right? So that means that the perspective is a bit different. Okay, now given that the perimeter of the shaded region is 20, so this is the perimeter of the entire thing is 20, express y in terms of x. Okay, so couple of things to note. If I want to find this, what do? R theta. My r for the big one is x. Theta is 1. X times 1 is x. Right. Okay. Now, what about the small one? So for the small one, it's almost the same. Okay. Because r times theta, right? So radius is y times theta, which is 1, is actually y. So it's quite interesting. Okay, that you find exact value. So it's quite easy for you as well. To find out this guy from here to here and from here to here, we know that we can find out by taking the long one minus the small one. So this should be, I'm just going to write it in red, x minus y. This is also x minus 1. So we kind of have all the values already. We just need to plug in to the perimeter. So we are given perimeter equals to 20. So I'm going to take all these values up. X plus y plus 2 times x minus y is equals to 20. Why I put 2? Because we have 1, 2. Okay, makes it look a bit cleaner. Expand 2x minus 2y equals to 20. Simplify, I'm gonna get about 3x minus y equals to 20. Okay, rearrange, I should be getting y equals to 3x minus 20. Okay, that's your final answer. Make sure that it's y in terms of x. So y must be standalone here. Your subject must be y. It cannot be a negative y. Okay, so you have to bring all the negatives to the right side. Okay, so the next one is, given the area of the shaded region is 16, express y squared in terms of x squared. This time it's the shaded region's area. Okay, so let's look at it. So if you look at this carefully, the shaded area can be found by taking the large area minus the small area of the sector. That's what I'm going to do. The formula is exactly the same. So half r squared theta minus half r squared theta. Big minus small. This must be equals to 16. Okay, so half, the large sector, the x is the radius, therefore this becomes x squared. Theta is just 1, so I don't even need to multiply. Okay, so here r squared is y squared. Theta is again just 1, I'm not going to multiply, equals to 16. So let's simplify this and put it in a way that's easier to look at. Aha. Now I see what I can do. It's just basic algebra. Remove the denominator and you will end up with x squared minus y squared equals to 32. Okay, I just times everything by 2 to remove the denominator. Now they want again express y squared, so I'm going to rearrange everything and I will end up with y squared equals to x squared minus 32. That's my answer. Okay, I think we have one last part of this question. Oh, yep. Now, find the value of x and y. So you are supposed to find x and y. How do we do it? We know that we have two equations. Assume that this is equation number 1 and this is equation number 2. All right? So what we need to do is we need to remove one of the either x or y. But it's quite easy. I can just substitute this entire thing into y squared, right? So I'm going to do just that. Okay, let me write down first so that you have a rough idea of what we are looking at. Okay, so we have, let me see, y squared equals to x squared minus 32, right? So yeah, that's what we have. Now, earlier my y was 3x minus 20. Okay, I'm just going to take this, put it here. 3x minus 20 squared equals to x squared minus 32. This is basically just simultaneous equation. Rearrange everything and expand, you will get 9x squared minus 120x plus 400 equals to x squared minus 32. Okay, I'm going to erase this for now because it's confusing. Okay, simplify, rearrange, and you should be able to get something like this: x squared 120x plus 432 equals to 0. Okay, and further simplify, divide everything by 8. I will have something like this. Okay. Factorize, you get this. Alright, so we have a situation where we have x equals to 6, okay, and then we have x equals to 9. Alright, now earlier, I'm bringing this back, we had the y equation, 3x minus 20. Now since we have found x equals to 6 and x equals to 9, right, what we're going to do, we're going to substitute inside. Okay, so y is equals to 3, 6, 20. Here I'm going to get negative 18. What about here? Here I'm getting y equals to 3, 9, 20. I'm getting 7. Now there is a problem here. Remember that the y that we are looking at is actually this. So this can never, it's a length. A length cannot be negative. Therefore, oops, we will not be taking this answer. Okay, so we will only be looking at this. Therefore, x equals to 9, y equals to 7. That's your final answer. Alright, I hope that you have enjoyed my lesson and you now know how to work on circular measures. So if you've enjoyed the content, please subscribe to the channel and do share with your peers who are also taking IGCSE and are struggling. See you in the next session.